Okay, so today we're obviously still looking at finance, and it's still all to do with, either investment, the compound interest. And so what this one is, a perpetuity is when you have an investment and it's an investment. So just remember your PV will be negative, but it's an investment where the payment equals the interest earned. So what that means is it's sort of like what you did the other day. It's the opposite to remember we had an interest only loan, so that was 9D. So where whatever the interest you had to pay on that loan, that was the payment. So really what you were doing, your loan was never reducing in value, because I said you're going to sell it later on, so you're not worried about that. You're just paying what the bank is charging you, which is the interest. With this is like an investment. So what often happens is sometimes say a university, they will be, they've got a bit of money. They got maybe someone, someone donated a lot of money to a department in a university. So what they do is they invest that money into the bank, and then they get this interest from it, and they make up an interest payment, and the payment is going to be all the interest earned, and they give it off as a scholarship. So really it's costing them nothing, because they're making money on their investment, and that's what they do. Other people, sometimes you'll see people might say grandparents, and they have their assets, they've got a lot of money, so they will set up and they will give maybe their grandchildren the interest earned as a payment. So that's a perpetuity. So they can set it up like that. Okay, so what you're going to see in the perpetuity, you'll see that the value of the perpetuity remains this constant. So in terms of finance solver, you will have your PV and your FV will be the same amount. Okay, it'll be the same amount. The only difference is when you'll see down here that PV is negative. So you'll see here, we've got it in our notes. So PV will be negative and FV will be a positive, but they'll be the same number, because that means you're investing. Now what happens is the payments will be a positive number, because that's what you're getting out and giving, it comes to you. So, and that's what we'll see. So we can, we've obviously got a recurrence relation, and we've set it up here. So where this R, if you look here, this R, so the big R will be the interest calculating, this will be the growth, and so the interest being added, and the D, so the D equals the interest being taken away, and that's why it'll remain the same. And so then that's like the payment, and it's the payment situation. All right, so they'll make a little bit more sense when we do some examples, so let's go do some. All right, Elizabeth invests her superannuation payout of $500,000. So that's going to win into a perpetuity. So as soon as you see that, you know that you can say this $500,000 will be your negative PV, because you're going to invest it into the bank. And it will provide a monthly income. So the monthly gave you away, the PPY is 12, and without using any of the initial investment. That's what a perpetuity is, yeah? We are only going to use the interest as the payment. So that was just another way of describing what that is. So if the interest rate for the perpetuity is 6%, so that's an I per annum, what is the monthly payment? So here, let's write the question is payment. So we can do these still on Finance Solver. So if we wrote this out, so we write all our Finance Solver things out, and remember we only want to have one without an answer there, so that we can just use Finance Solver. So if we go through this, So when you're doing a perpetuity, for n, for the number of things, just always put in one period. So why are you going to do that? So it doesn't matter if it's monthly, weekly. You're only going to do that because you know the balance never changes. So just to see what one payment it is, we'll always put a 1 there. So the interest rate we're going to put is 6. And just to show you on your summary sheet up there, it's telling you that as well. Can you see here it says the n equals 1? So that will remind you. Okay, so we put the 6% in. Now PV, remember, it's going to be negative 500,000 because you're investing that. The question is payment, so I'd leave that. Now in a perpetuity, the FV is the same as the PV, but it's positive. So see how those two numbers there? They're the same. It's just the sign that's different. Okay, so then we pop that in and we know that it's monthly and we need to pop that in. And obviously if we do that on our calculator, we'll get the payment. So let's go do that. Okay, so hopefully you got 2,500. So that is the monthly payment. So the monthly payment and also the interest on this is also 2,500. Just to pop into your notes, when you have a perpetuity, when that is graphed, so when you graph, say, the value of your investment over time, just remember this is going to be a straight graph, okay, because it never changes. So say that will be on 500, in this example, would be 500,000 because you're always taking out the interest. So you might just pop a note there. Okay, how much money will need to be invested into the perpetuity account earning? So here we go, we've got 4.2% compounding monthly. So we knew PPY was 12. If 200 is to be withdrawn, so we've got to know that it's a perpetuity, and 200 is being withdrawn from the account each month. So that is the payment. So really, when they ask what will need to be invested, this is when you're actually trying to find the PV. Now, if I just quickly wrote down our finance solver things, so if I do them down here, so I'm just going to show you. So we'd write all these in. Okay, so if I was writing in everything, so we know when we have a perpetuity, we just need to put 1. We've got the interest rate, 4.2. Now, PV is the question, so I put that there. Payment is 200, and it's positive because it had come to you. Now, and I know PPY is 12. Now, if you notice, this is the question, this is missing, but this is also missing. And they're the same, aren't they? These two values would be the same. But you can't do it this, you can't find the initial investment on your finance solver when it's a perpetuity because there's 2 missing, isn't there? And you can only have 1. So that's why I want you to write a title under this bit. So we're going to say when you're finding investment, and we might just write the PV in brackets, amount of a perpetuity. So you have to do it this way. So what happens is you get so used to using Finance Solver a lot, and then you'll get up to this and you'll forget. You'll go, oh my gosh, what am I going to do? So this one we have to use the formula. So up here if you look up in the formula, up here, remember this D value up here is actually the payment, yeah? And if we wrote that, we'll write out the formula. So D equals R over PPY over 100 times VO. Now, if we remember, PV is actually our VO, isn't it? It's our initial value. So what you can do is you can substitute everything else in. Now you know the payment was 200 in this case, and you know the interest rate was 4.2, and you know PPY was 12 over 100, and then we're going to just times. Now instead of writing VO, we'll just use X, yeah? So I'm just going to use the letter X, and what we can do is go solve and comma X, and X is obviously whatever it is, and over here in a side note you can just say that X obviously equals VO or the PV. So we'll do that in our calculator, so give that a go. It's set to the nearest dollar up here, so when I find my answer, I got that the initial investment was $57,143, so dollars. Okay? So maybe pop this little note on your summary sheet, on your back of your notes, in there so that you can remember that's what you need to do when you've got to find, even if you want to write PV, or you might write investment amount, because that's probably what they're going to ask it as. Okay, so let's go through this question. A university mathematics faculty has $30,000 to invest. It intends to award an annual mathematics prize of $1,500 with the interest earned from investing this money in a perpetuity. So they were nice. They told you it's a perpetuity. So you can go through and write in a few of your things here. So we know that this is our negative PV and our positive FV. You might write that. This is your payment, and it would be a positive because you would be getting it. And then it said, what is the minimum interest rate? So I is the question. And so you can see we've popped everything in, and it says to be awarded annual. So that is how you know PPY is 1. So the annual, it means it's once a year. So we can fill in all the things in our finance solver, and the only one missing was the interest, and you can see that's how we got 5% per annum. Okay, a scholarship will be set up to provide an annual prize of $400,000. So there's that annual prize of $400 for the best mathematics student in the school. The scholarship will be paid by investing an amount of money in a perpetuity. So investing, and it's going to pay 3.4% per annum, compounding monthly. The amount that needs to be invested, so this is the question, amount that needs to be invested is closest to. So really what we're saying there, that's the PV question mark again. So I've put we'd be here on our formula sheet where we've now written this is how we find the investment amount. Okay, so we can't use our finance solver for this, so off we go again. It would be another example of that. And if we just go through the annual prize, so that means that's the payment. Okay, so that means that's the D value. So here, write the rule out just to show you. Times VO, and then if I substitute in, it'd be 400 equals, now 3.4. Now because it's an annual award, there you go, annual, so PPY equals 1, would be 3.4 over 1 over 100 times the VO, which we're just going to pop in as X again, and we'll do our solve, comma X, and let's see what we get. Yep. Okay, so I got X to equal 1176 5 if we round, and there's it's saying is closest to, so there's no other one that's closer to than this one, so we would go with D. Okay, Samantha inherited $150,000 from her aunt. She decides to invest the money in an account paying 6.25% per annum interest, compounding monthly. If Samantha deposits her money in a perpetuity, what monthly payment would she receive? So if we go off and do A, so when we're doing the payment, we can use Finance Solver. So it is a perpetuity. So we'll pop in all our things that we've got to pop in. So with the perpetuity, we can write N as one payment, and we've got the 6.25, and she inherited, so she's investing, so it's a negative 150,000. Now the payment's the question, so that's the one we should have a blank on, and FV will be the same as PV but positive, and PPY was compounding monthly, so PPY is 12. So 12. So we pop that into Finance Solver and we'll get our answer for payment and have a look at that. So we get a payment of 781.25. Now B, if Samantha deposits her money in an annuity and withdrew 1,000 per month, how much would she have in the account 1 year later? So here we're going to keep on using our Finance Solver in B, but we've now changed to an annuity. So when we say 1 year, so there'll be 1 times 12 months, the interest rate is still 6.25. She's still investing in an annuity, so it'll be 150,000. Payment is if she withdrew 1,000 per month. So remember the payment will be positive 1,000, and FV is the question. So how much will she still have? And PPY is 12. So we'll pop that one in and we'll get our answer for that. Okay, so with that one I end up with, just going to rip that out and write it, $147,298.48. Okay, let's move on to C. So if Samantha deposited her money in an annuity, and withdrew 2,000 per month, how long would it take the investment to drop below 100,000? So what you sort of want to do is say that your final value is this 100,000, and the how long would be make the N the question. So we can still do it through Finance Solver again, and obviously just got to change that payment as well. So how long, so that's going to be our question. The interest rate is still 6.25. They're still investing 150,000, so we'll pop that in there. The payments are now 2,000 a month, so PPY is 12, and we want the value to be 100,000, so we're going to see when that happens. So we'll pop that in, and this one will become the blank one, and we'll check that. Okay, so we get that to be 37.2, or we should say 0.3, and so that would be 37.3 months. So we're just going to say by 38 months it would be below, it'll be below 100,000. So we'll just go to the next closest month to that one. Okay, if Samantha deposits her money in an annuity and withdrew 4,000 per month, how long will the investment last? So we're still going to be using Finance Solver here, and I'll do this first one, how long? So that would be the N is the question. So we'd have N, we still have the interest as 6.25. The PV is still negative 150,000. The payments are now 4,000. And it says how long would the investment last? So what you actually want FV would be to zero it out. So how long would this go for before it was 0? So FV will be 0, and PPY is still 12 because it's still monthly. Okay, so we get 41.8 8 months. So we'll just say, it didn't really say, so just leave it with a rounded 41.8 months. So it says, including interest, what would be the value of her last withdrawal? So I was just going to move up the data here. Okay, so just ran out of room, so I've created a new page. So we're up to, that was DI, so we're up to this one. It says, including interest, what would be the value of the last withdrawal? So because it doesn't quite make 41.8 months, what you can do is either, we're going to say, well, you get the 41 months at the 4,000, and the last one is going to be a little bit less than the 4,000. So what we're going to do is, find the final value, because it was 41 months, 0.8, we're going to find the final value when at 42 months. So I'm going up to the next one, and because we would still get interest in that 42nd month, so we want to make sure that's added on. So because at 41 months she gets 4,000, so we're going to go, and there's still money left, so we'll go and try and go for one more month, but we know it's not going to be the full amount. So if we go find what the final value is, knowing this, that it should be finished by 42, let's go find out what the final value is. So I'm going to put a question mark here, and PPY is 12. So when we do that, we'll see that we get a negative 676.93. So we have to remember that a negative means we owe the bank. We owe bank. So she would have, if she kept going for the 42 months, she would have taken out that last 4,000, but also owed the bank 676. So what we're going to do is we're going to adjust the last payment. Adjust last payment. So how we're going to do that is we're going to do 4,000, and we're going to minus what she owed the bank, which is 76.93. So her last payment is going to be that. So 4,000 minus 676.93. So we get, her last payment will be $3,023.07. So that's if you go on to do the extra month that way. The other way is you, and this is where they'll have to be very clear on the exam. You could have stopped at 41 months and seen what was left and added it to 4,000, and then that would have been a bigger payment. So it depends which way. So they need to be very clear. On a SAC, you'd get answered both. If they haven't been clear, well, technically you're both right. So just to show you what I mean by that, so we'll just say, or we could have done N at 41 months and found what the final value was, and then we would have added, she could have had a bigger payment at the 41 months. So let's work out what that was, and that would have been added. So let's just do. Okay, so if you do it that way, you end up with 3305.85. So that would be still owing to her, to Sam. So at 41 months, she could have got a big payment of the 4,000 plus the 3305.85. So she could have had a 7,000. So it depends on which way she wanted it. If she wanted to, stop when she couldn't get the 4,000 anymore, or generally what you would see would be this option here. But I think they need to be clear. But if you write out and you're showing like what I'm showing, what you would get, so you should be fine. So if you wrote the big payment, and as long as you explain it, you're getting it correct. Okay, in this question, Jointa invests 80,000 in a perpetuity that will provide 4,000 per year to a scholarship fund at a university. The graph that shows the value of a perpetuity. Now we wrote earlier that the value of investment in a perpetuity, I can't even say that word. The value of an investment in perpetuity remains the same. So you're going to see a flat horizontal line, and you can only see that one here. There's that flat horizontal line. Now, she's got to get 4,000 a year, and that's why this one, the other flat one, isn't going to make it because it's so low. You're not going to be able to provide a payment of 4,000. So, and she invests 80,000, so it has to be this one. Yeah, so they told you, so it's going to remain that one. Okay, which one of the following recurrence relations could be used to model the value of a perpetuity investment after n years? Okay, so if it's a perpetuity, the investment needs to remain the same. So that means when we see these D values need to equal the interest earned for it to be for it to be a perpetuity. So what you can do, this part here, remember this here is like the R. So the R would have been found by going 1 plus the rate over PPY over 100. Okay, so the 1 is the whole amount, and when you see this part of the formula, this part of the formula is the interest earned. So what you can do is to check it. All you need to do is times that part, which is actually this part of the formula. So you times that number by your initial value. So what I'm doing is I'm going 0.047 times the 48,000, and you see what that equals. So if I do that, okay, so when we do that, that equals 2256. So for this to be a perpetuity, this number here would have to equal that, and it doesn't. So this is not the answer. So then I would do the next one. So where I'm just going to use I just want to see what interest is gained. So we go 0.076 times the 52,000 and see what we get. And we get 3952, so it doesn't match that, so it's not that one. So I do the next one, 0.46 times 56,000. So what would that one be? So that was 2576, so it's not the same. The next one, 0.076 times 57,000. Okay, and I get 4332. So it does match that, so this one is the perpetuity. So whatever it gained, it's getting taken away, so the final balance will always be 57,000. Okay, so here's an exam question. So which one of the recurrence relations used to model a perpetuity investment? So once again, we can do what we just did before. If it's a perpetuity, the interest gained equals the payment. So what we know, that interest gain is that little bit, the RPPY over 100 bit. That's the interest you're gaining, and it'll equal the D amount. So we're just doing like what we did before. So what we could do is we're just taking the bit that earns the interest, which is that bit. So 0.0029, we're timesing it by the initial value, 120,000, and we see what that equals, and we get 348. So it doesn't equal that, so it's not that one. And then you do the next one at 0.0047 times the initial value, which is 180,000, and equals. So I get 846 for that one. which does match. So I'm going to say that's the answer. When you would stop and keep going with your exam, and then when you come back to check that these ones are not correct. So then you'll know you're checking something different and hopefully you're right. So only 59% of the state got that correct. Okay, so here's a couple of exam 2 examples. So Julie has retired from work and has received a payment of $492,800. She has 2 options for investing. Option 1, Julie could invest $492,800 in a perpetuity. She would receive $887.04 each fortnight for the rest of her life. What is the annual percentage rate is this interest earned? So you can do, because it's pretty much what they're asking you here, the annual percentage rate is in Finance Solver, that's the I they're asking. So if we did it over here, remember in a perpetuity, we say N is 1. So the interest rate is my question. PV is what I'm investing, and it should be negative $492,800. The payment is going to be positive, and we've got 887.04. FV is always the PV, but positive, so 492,800, because they remain the same, and PPY, it says a fortnight, so there's 26 fortnights in a year, so that's 26. So we'll pop that in and we'll get our answer for this. Okay, so we do that and we get 4.68%. So that's the annual, so 4.68%. Julie could invest the money in an annuity instead of a perpetuity. The annuity earns 4.2% compounding monthly, and the balance of Julie's annuity at the end of the first year would be this. What are the monthly payments? So what we have to look at is a few things. So this is obviously PV, and it'd be negative because it's investing. This is the I, and compounding monthly PPY is 12. Now they've also given us the thing, they said at the end of the first year. So this would be N is 1 times 12, and it's pretty much telling me that the final value is this much. So when you have all that information, you can see payment is the question, and it will be the only one you don't have. So if we popped it into Finance Solver, I'm going to use the end of the first year scenario, because that means I can pop in everything into my Finance Solver. So it's an investment still, so this PV is negative. The payment is a question, and FE is the positive, this amount that they gave us for the end of the first year. And PPY, because it's monthly, make sure it's 12. So we can pop that in and we can get what the payment is. Okay, so we get 2,800. So the payment would be 28,000, like that. Sorry. Alex sold his mechanics business for $360 and invests it into a perpetuity. The perpetuity earns at 5.2% per annum, and interest is calculated or paid monthly. What is the monthly payment? So this is the question here. So if we go through, this is my negative PV and also my positive FV because it's a perpetuity. This told me the I, and this told me the PPY was 12. So if we wrote all them out, I'll just do it across this way. So remember, in a perpetuity we can have 1. Okay, so the interest rate is 5.2%. PV is negative 360,000. Payment is my question. FV is the positive PV because it's a perpetuity, and PPY is 12. So we can go find that out. Okay, when we do that, we get an answer, the payment as 1560. Okay, later Alex converts the perpetuity to an annuity investment. The annuity investment earns 3.8% per annum, compounding monthly. So when it says it converts this perpetuity to an annuity investment, you do know what this PV is, because remember the perpetuity the value never changes. So your PV is still going to be negative 360,000. Compounding monthly, so we've got PPY of 12, and this is our new interest rate. For the first 4 years, Alex makes a further payment each month. So he's making extra payments to his investment. So this is going to be the payment, but it's going to be a negative payment of 500 because he's actually adding it into the bank. So it's going to the bank, it's negative. This monthly payment is made immediately after interest. They have to write this to know that it's like to say that they're matching up. So the payments and the interest are the same PPY. After 4 years of these regular monthly payments, Alex increases the monthly payment. This new monthly payment gives a balance of 500,000 in his annuity after a further 2 years. What's the value of his new monthly payment? So this is like a change of scenario. So the first thing we want to do is know what he still has in his investment after these first 4 years. So I'm going to go into finance server. So before times 12, the interest rate is 3.8, PV is negative 360,000, and he's adding extra payments, so that's negative 500, and we want to know what this value is at the end of those 4 years, and PPY is 12. So we'll go pop that in to finance solver. So his investment is now up at 444,872.94. So now we've got that. So after, we're going to go into the next scenario. So after these 4 years, the regular Alex increases his monthly payment. The new monthly payment gives a balance of 500,000 in his annuity after a further 2 years. So we're now going to go, we've got a final value for another 2 years. So we would say 2 times 12. But what we're going to do is pretend we're starting again. So we'll go again. So we've got N, and we're going to use the 2 times 12. The interest rate, it didn't change, it's 3.8. Now the PV, this is the next scenario. So we're actually putting what he's gained up to into, we're like pretending it's a new investment. So that has become a negative, so 444,872.94. The payment is the question. So that's what we're trying to find out. And FV, we know he gets it up to a balance of a positive 500,000. So that becomes like the new balance, and PPY is still 12. So we pop that in and we'll get an answer. Okay, so we see you get this payment of negative 805.65. So you have to answer the question. You can't leave it like that. It says what is the monthly payment. So you definitely have to write that the monthly payment equals, and you've got to write it as a positive because that's actually what he's putting into the bank. That's what he's making these new monthly payments into the bank because he wants this investment to keep growing. So